In this video, we will delve into the Reynolds number and its formula. Let's start by defining the Reynolds number. The Reynolds number is a dimensionless quantity that compares the ratio of inertial force to viscous force, and it's represented by the formula Re as the Reynolds number is equal to the inertial force divided by the viscous force. These forces can be expressed as rho times V times L for inertial force divided by mu for the viscous force, or simply capital V times L over the small letter v, where rho denotes the density of the fluid, capital V is the velocity of the fluid, L represents the length or diameter of the fluid, mu for the dynamic viscosity of the fluid, and small v is the kinematic viscosity of the fluid. Now, let's understand how this equation is derived. We start with the inertial force. In Newtonian mechanics, the inertial force is described by Newton's second law of motion, which states that force is equal to mass times acceleration. So the formula for our inertial force is F sub I, representing inertial force, is equal to mass m times acceleration a. However, since we're dealing with fluids, we replace mass with density rho times volume v, which we obtained from the density formula. Also, we know that acceleration is equal to velocity over time. Thus, we also replace a as v over t. Hence, the formula for inertial force becomes density rho times volume times velocity over time. Or, we can write it this way. But this volume over time here is actually the volumetric flow rate, denoted by Q, because by definition, volumetric flow rate is the fluid's volume per unit amount of time. Therefore, we replace volume over time with Q. And take note that Q is equal to velocity times area, so we replace our Q as V times A. Thus, our inertial force formula simplifies to rho times V times A times V, which further simplifies to rho times A times V squared. Moving on to the viscous force F sub V. It is determined by multiplying the shearing stress and area. Shearing stress, denoted by the symbol tau, is equal to mu times du over dy, where du over dy represents v for velocity and L for length, respectively. Therefore, the formula for the viscous force is mu times v over L times A. Substituting our formulas for inertial force and viscous force into the Reynolds number equation and simplifying by canceling out A and V, we arrive at rho times V times L divided by mu. Another way to express this formula is by noting that dynamic viscosity mu is equal to density rho times kinematic viscosity V. Simplifying further, we cancel out the rho and are left with capital V times L divided by the small letter v. And that's it. That is Reynolds number.